Good day, sir. I am Deck Cadet Abarques Christian Joy, and we are Group 1. And my group members are Armanel Justin, Cantuna Rigi, Cudrilon Christian Ed, Consento Luis, De Los Santos Eunices, Dolinti Van Joshua Villahermosa, and Domdom Christian Ivan. So our given topic, sir, which is ship handling and maneuvering. So first topic, which is principles of ship handling. Ship handling and maneuvering is defined as the art of the proper control of the ship while underway, especially in harbors, around docks, and piers. It is one of the skills that any ship handler finds very satisfying when well accomplished. The most basic thing to be understood in the ship handling is to know and anticipate how a ship behaves under all circumstances, and what order should be given in order to make the ship behave and move exactly the way you want her to. So the difference between the ship's heading and the actual direction of the movement of the ship should also be constantly attended to, as this essentially important at slow speed and when there are wind and current. So the three basic ship motions: first, the longitudinal motions, which is forward or astern; second, the lateral motion, which is sideways; and third, the rotational or turning motion. So vessels also have the other behavior worth nothing when her maneuvering equipment is in operation. Depending on the type of proper propeller, a ship with a single propeller, when run ahead from stop cants to either port or starboard, when to put asterns from stop to stern cants at a fast rate to port or starboard, when a ship has headway and the rudder is put over the one side and the boat turns to the same side where the rudder is turned. Thrusters, on the other hand, move the vessels end sideways. Thrusters depends on its design, increase effectiveness as the vessels slow down. So that would be all, sir, for my given topic, sir. Thank you.
So the most basic thing to understand in ship handling is to know how to anticipate how a ship behaves under all circumstances. So as a natural ship handler is a person who blessed with the ability to make his ship do exactly what he wants when he wants. Most of them must learn the art of ship handling by studying the theory of ship handling and backing that up with practice on board under safe supervision. As more safe handling simulators become available, you may get an opportunity to practice on a good ship handling simulator supervised by a qualified instructor. Simulator exercises supervised by a professional instructors that are most efficient and safest way of ship handling training available today. So next is ship handling and maneuvering is applied in physics. Ship handling is both science and art. It is science because it requires knowledge of various forces acting on the ship. It is art because it requires the skills of an experienced navigator to use forces in his favor. It can only achieve by learning both the science and the art of ship handling. So it must have sufficient understanding of the vessel's capabilities so as to prevent the vessel reaching dangerous position from which it is unable to escape safely.
Three basic motions of the ship. So first, why the ship moves. The ship moves because of the reaction of the force of water on the ship's hull. And when the propeller rotates, the water particles are around the blades also rotate because of the force of the propeller. So when the propeller moves, it throws water away from the ship, which has an equal and an opposite reaction to the propeller shaft. So these are the three basic shapes motions. So first is the longitudinal motion, and the second one is the lateral motion, and the third is the rotational or turning motion. So first is the longitudinal. So it means longitudinal, it is a forward or astern. So magkita sa ito forward or atras. And the second one is a lateral motion, or as we can say, it is sideways nga movement. So side to side ang yung movement. And the last is a rotational. So pag it means rotational, it can rotate or on turning motion.
Deadweight tonnage or DWT. Deadweight is defined as the maximum deadweight of the ship and measure of the ship's carrying capacity. It takes into consideration the weight of the cargo on board, fuel, ballast, water, fresh water, crew, provision for the crew, including the weight of the ship in the calculation. It is a measure of a ship's ability to carry various items: cargo, stores, ballast water, provisions, and crew, and etc. A large part of deadweight is used for water ballast, necessarily to meet stability requirements. To calculate the deadweight tonnage figure, take the weight of a vessel that is not loaded with cargo and subtract that figure from the weight of the vessel loaded to the point where it is immersed to the maximum safe depth. Only in the case of heavy loads put at the bottom, the hold greater deadweight translates automatically into greater amount of cargo. Draft. The draft or draught of a ship hull is the vertical distance between the afterline and the bottom of the hull or keel. The draught of the vessel is the maximum depth of any part of the vessel, including appendage such as rudders, propellers, and drop keels if deployed. Draft determines the minimum depth of water a ship or a boat can safely navigate.
I'm Cadet Dumdum. Trim. The trim of a ship describes its floating position in length direction, namely if the bow or the aft of the ship is deeper submerged into the water. The trim can have a significant impact on a vessel energy demand for propulsion during sailing. Speed. Ship speed plays a very important role in various environment factors as well as economy factors for the operator of this vessel. Speed of the ship has a non-linear relationship with fuel consumption. The ship which will go slower will have fewer air emission than a ship going faster. Speed of the ship has an impact at both design level and operational level. Different types of a ship. Different types. Service speed of carriers 13 to 15 knots, container ship 16 to 20 knots, 24 knots, oil and chemical tanker 13 to 17 knots, ro-ro vessels 16 to 12 knots, cruise ship 20 to 25 knots. Different types of ship have different drops, different cargo, different design, hence accordingly different service speed.
turning circle. When a vessel is made to turn under a continuous helm throughout 360 degrees, it will follow a roughly circular track called turning circle. So you can see in the picture below where the initial movement of the starboards will approach at zero helm to its advanced maximum transfer, and the TCD or tactical diameter in the maximum advance where it has already reached 180 degrees, and next to its drift angle and the path of ship's center of gravity to its full 360 circular motion.
So next is the underkill clearance, or the UKC. So it is to ensure that safe navigation while approaching shallow water. So it is the responsibility of a captain or the master of the ship. He or she must calculate precisely the underkill clearance requirement for a vessel to ensure that it remains afloat at all times. So as you can see at the illustration, the underkill clearance is a vertical distance between the deepest underwater point of the ship's hull and the water area bottom or the ground. So that clearance should be sufficient to allow ship's floatability in most unfavorable hydrological and meteorological conditions. So the importance of the underkill clearance is that it is a very important factor and contributing factor among many factors that influence the safely navigation. So especially in shallow water and the restricted water or restricted areas. So the factors that affect UKC include types of ships, navigation conditions, speed, water depth, the drought, wave, wind, flow, and etc. So what is the importance of underkill clearance in passage planning? So as what I have said earlier, that the underkill clearance is to provide safe navigation through areas which has restricted water or shallow water. And also it is enhancing safety of shipping and protection of the environment.
Good day, sir. I'm Cadet Codrion and I'm going to report about stopping distance. So first, what is stopping distance? So stopping distance is the distance which a ship will continue to move after action is taken to stop engines until the ship comes to rest. Stopping distance details may be provided for sea speed, harbor speed, half speed, etc. May be provided for loaded and line conditions. So stopping distance, unlike sa sakyanan, if we engine stop ang sakyanan or atoy brake, literal nga muurong largo ang sakyanan. Unlike sa ship, i-engine stop nimo, ari mismo i-engine stop, mo free flow pa na siya. Napanay distance ma-covered niya. So, munang gitawag na stopping distance. So, example, engine stop ka dire. Engine stop mo drag siya. Hantod, kung asa siya sa from engine stop, ari ka nga time nga ni engine stop to distance where na ni stop na imo vessel, muna ang distance nga gitawag nilang stopping distance. Importante ni kay example mo ato ka sport, dapat ikaw mismo layo pa lang mo engine stop na ka estimated na nimo. So para ikabot adto dool na sport, fully stop na imo ship. So dako og ang sa important role ani kanang mga sea condition, wind condition, and loaded ba imo ship or light conditions ba imo ship, kay dakog impact sa imo stopping distance na sila'y tungod ana sa mga condition nga na malahi-lahi imo stopping distance. So unay important nga mga kuan nga imo ang dapat. So that is the stopping distance.